Lines in the coordinate plane. Our objectives are to graph lines and write their equations in slope-intercept and point-slope form, as well as classify lines as parallel, intersecting, or coinciding. Why learn this? The cost of some health club plans include a one-time enrollment fee and a monthly fee. You can use the equations of lines to determine which plan is best for you. Forms of the equation of a line. You have point-slope form, which is where you would have y minus y1 equals m times the quantity x minus x1, where m is the slope and x1, y1 is the given point. Slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So b is where your line crosses your y-axis. The equation of a vertical line is going to be x equals wherever that line happens to be. So if it goes through 5, x equals 5, but it's for vertical lines. Horizontal lines use y equals, and it's whatever that y-intercept was. So wherever it crosses the y-axis, maybe it's 2, then y equals 2, and it would be a horizontal line. So let's look at a couple of examples. For this first one, we want to write an equation in point-slope form. We're given a slope and we're given a point. Generally speaking, that's like the first move when you're trying to use point-slope form. You have a point and you have a slope. Well, plug it into your formula. Your formula is y minus y1 equals m times the quantity x minus x1. So when we substitute, we're going to substitute our slope. So m is our slope. And we're going to substitute our y1 and x1. So it's always an xy coordinate, so x1, y1. So we have y minus 1 equals 3 times x minus 2. And it is now in point-slope form, so you are done. Let's look at B. The line through 0, 4 and -1, 2 in slope-intercept form, while slope-intercept form was y equals mx plus b. M is your slope, and then b is where it crosses the y-axis. So we want to start with finding our slope. So our slope is the change in y over the change in x. So we have 2 minus 4 over -1 minus 0. So we have -2 over -1, which is simply 2. And now we can substitute. So we have y equals 2 times x. And then we want to figure out what our slope is. So we're still running shy. Or not slope. We want to figure out what our y-intercept is. Well, you can do it in two ways. You can notice that this coordinate is your y-intercept, or you can plug these values in and figure out what b will be. So we have 4 equals 2 times 0 plus b. Well, 2 times 0 is 0, so 4 equals b. So therefore, you have y equals 2x plus 4. If you realize that this was your y-intercept, it would have been one step less to be able to figure this one out. Let's look at a couple more examples. So we want the line with the x-intercept 2 and y-intercept 3 in point-slope form. So we have y minus y1 equals m times x minus x1. Alright, well, your coordinate for your x-intercept of 2 will be 2, 0. And for the y-intercept of 3, that's going to be 0, 3. That way you have two coordinates you can utilize. So we want to start with finding our slope. So our slope is the change in y over the change in x. So we have 3 minus 0 over 0 minus 2. So 3 minus 0, and then 0 minus 2. So we now have 3 over negative 2, and that will be our slope. So now we have y minus y1 equals 3 over negative 2. And we've got x minus x1. Alright, well, we need to substitute in a coordinate here. It doesn't matter which coordinate you pick, you just have to pick one of them. In this case, my suggestion would be to go with the x-intercept, because then we can eliminate one side rather easily. So we'd have y minus 0, because we're going with this one here, equals negative 3 halves, and then we have x minus 2. Well, what's y minus 0? Just y. So we have y equals negative 3 halves times the quantity x minus 2. Let's look at one more example here. And this one wants to be in point-slope form as well. So once again, y minus y1 equals m times x minus x1. So our first step is going to be to find our slope, because no matter which equation we're doing, we do need our slope. So we're going to have 2 minus 2 over 1 minus negative 3. So 2 minus 2 and 1 minus negative 3, which gives us 0 over 4, which is 0. So our slope is 0, so we now have y minus y1 equals 0 times x minus x1. And then we can plug in, doesn't matter which value you pick, you can either pick this coordinate or this one here. So then we have y minus 2 equals 0 times x minus negative 3, so plus 3. But it's 0 times this quantity, so this whole side of the equation, no matter what you plugged in, even if you put in the 1, it would still be 0. So you have y minus 2 equals 0. Alright, well, now that you can do the equations of lines, let's look at graphing lines. So this is in the form y equals mx plus b, so you know that that is your y-intercept. So it's where it crosses the y-axis. So you know you have one point that's here. And you know that this is your m, so you know that's your slope. And it's 3 over 2. So your rise is 3, and your run is 2. Well, 1, 2, 3 kind of puts us off of our grid. So if we went down 3, we would have to go left 2, because a negative divided by a negative is a positive. So if we went down 3, 1, 2, 3, and over 2, it would essentially be the same as if we went up 1, 2, 3, and over 2, and ended up somewhere over here. Because your slope is still going parallel, because if you went negative, negative, it's still going to create a positive slope. And then you can just graph your line. And that's that one. So let's try another one. Alright, so we have y plus 3 equals negative 2 times the quantity x minus 1. To do this, you want to know what your slope is, and you want to know what the coordinate is you're looking at. So, in this case, your slope is negative 2, so you can write that as negative 2 over 1. And then the coordinate, it's an xy coordinate, so you're always looking at xy for coordinates. So your x value is positive 1 because it's minus 1 in the or minus x in the formula. So you have a 1. And notice how you have a plus 3. Well, the formula had a negative sign or a minus sign in it, so if you subtract a negative, that's what's making it positive. So therefore, it's a -3. Some have found it easier to think, whenever you're dealing with point-slope form and you're trying to find your coordinate, just think opposite, and you'll be okay. You can try that as well. So we have our point, which is 1, -3. So 1, -3. And then you have your slope, which is down to the right 1. Or if you went up 2, you would have to go to the left 1. Because keep in mind, -2 over 1 is the same as 2 over -1, which is the same as negative and then 2 over 1. It doesn't matter where the negative appears. If it's a negative, as long as it appears once, you're okay. So, and then you can draw your line through there. And there's your line. All right, let's look at one more example for graphing. X equals 3. All right, well, if you recall back, whenever your x equaled something, it was either going to be a horizontal or vertical line. Well, think of it this way. All of your x values have to be 3. So all of your x values, no matter where you go, have to be 3. So therefore, it's going to be a vertical line at 3. And there you go. All right. Let's look at pairs of lines. We've already talked about the fact that if they have the same slope, then they're going to be parallel. Well, if they have to have the same slope in different y-intercepts, so that way they're actually different lines. Otherwise, if they have the same slope and the same y-intercept, they would be what's called coinciding, like right on top of each other. And intersecting lines simply have different slopes. So let's use that knowledge to try to classify pairs of lines. So if we look at A, we have y equals 2x plus 3 and y equals 2x minus 1. Well, your slope is 2 in the first equation and it's 2 in the second equation. So we know that it's either got to be parallel or coinciding. For it to coincide, the entire equation has to be exactly the same. It's not. You have plus 3 and minus 1. So therefore, it's got to be parallel. So these ones are parallel. All right, let's look at this next pair. We have y equals 3x minus 5. So your slope is 3, and it's going through -5. Then we have 6x minus 2y equals 10. We need to get y by itself so we can really easily see what exactly is going on with this problem. So let's start by solving for y. So we're going to subtract 6x from both sides. So we're going to have -2y equals -6x plus 10. So we're subtracting our 6x from both sides here. All right, and then we have to divide by -2. So we're dividing the side of the equation by -2. And remember, you're dividing the whole side of the equation by -2. So you're going to deal with it with the 6 and with the 10 because it's a binomial. All right, so we have y equals 3x, and then we have minus 5. All right, well, that's the same exact equation as our first one, so we know that these ones must in fact coincide. Let's look at the third example. We have to get y by itself in both of them. So let's start by subtracting 3x from both sides in the first equation. And you have 2y equals -3x plus 7. And then you're going to divide by 2 on both sides. So you have y equals -3 halves x plus 7 halves y, plus 7 halves is your y-intercept. And I'll change colors so that we can do the next one. And for our next one, we have 3y equals 4x plus 7. So we want to divide by 3 on both sides. So we have y equals 4/3 x plus 7/3. Well, their slopes are definitely not the same. So you know it can't be parallel or coinciding. And therefore, it must intersect. So these ones intersect.